One of the biggest mistakes with u-substitution that many of you are making is you're just giving up too quickly and going in circles because you don't think you can use that method for an integral like this. But by the end of this video, you're going to see why you actually can use a u-substitution. Before I reveal how, let me introduce myself. I'm Dave, and I used to tutor students like you back in college, and I'm actually a software engineer where I've made some fun apps. You can check out the Number Ninjas math game below in the description if you want to sharpen your mind on your next exam. But without further ado, let's go ahead and crush this like a ninja. So you maybe already tried this u-substitution here, where you let the original denominator be this new variable. And this is probably where many of you are getting stuck, because when you take the derivative of both sides, you get 3x squared plus 3 here on the right. However, in the original problem, we don't have that polynomial expression on the top. We have x squared plus 1. But this is where you shouldn't just give up, and look at it carefully, because these kind of shortcuts can actually be on your next exam. Take a moment now, take a breather, and look at the relationship between 3x squared plus 3 and x squared plus 1. What do they have in common? Okay, if you don't see it, imagine I had a 3 up here and I was multiplying the numerator by 3 times all of this expression here, right? X squared plus 1. You would get the same polynomial here, yes? So with that being said, why don't we just factor out 3 from both terms here and see if that gets us anywhere? Because now we would get du equals 3 all times x squared plus 1 dx. And then it's more obvious now that, okay, well, we didn't have a 3 in the original problem, but we did have x squared plus 1 dx in the original problem. So to make the right-hand side match the original integral where we can actually do a u-substitution, you would divide both sides by 3. Ta-da! And then now that you have du over 3, when you substitute all of this in for dx into the original integral, well, with du over 3, dividing by 3, giving you, 1/3, I just pulled it outside of the integral to make this blatantly clear that this is a very simple natural log of the absolute value of u times 1/3. And I'm going to show the plus c at the very end after plugging in what u is, which we know from our substitution was this polynomial expression. So I hope this was pretty easy to understand, and if you want more u-substitution practice before your next exam so you can crush it like a ninja, definitely check out this video you see.